Good morning, students. In our previous class, we have discussed about algorithm and flowchart, a brief short discussion about algorithm and flowchart. And my dear students, this is Tripathi, your computer teacher, and we are discussing on Scholar Public School online teaching platform. And today we are going to discuss about rules for writing an algorithm. What are the rules to write an algorithm, and what is your algorithm? Algorithm is nothing but the planning before to process the program. Before to process the program, we are making a planning, and that planning is known as your algorithm. What are the rules for writing an algorithm? Let's come on that point. An algorithm should be written in English-like language. Okay, it should be written in English language. Wait, students. Thank you, sir. Next, it should be written in a simple and precise manner so that everyone can understand it. Okay, it should be written always in a simple and in understandable language so that everyone can understand it properly. By reading the process of brushing the teeth, my dear students, I think so that do you get any problem to understand it? No. In that only simple language, we should write the algorithm before creating the program, so that everyone can understand it easily. An input is required to write an algorithm. Okay, so we should provide an input, the methods, like take your brush from the shelf. Each step should be written in a sequential manner, one after another, sequential method. Okay, एक के बाद एक, जैसे 1 2 3 4 5 6 7, this is what sequence. Okay, in that way. One can include variables and define mathematical expression to calculate the result. Okay, हम लोग उसमें variables जैसे a b c का भी यूज कर सकते हैं और mathematical logical process का भी यूज कर सकते हैं in that expression only to get the mathematical result. Statements that are of similar type should be combined to avoid a lengthy code. Okay, when the statements are of similar type, we should avoid it. Well, we should combine it together so that the code shouldn't become lengthy. Each instruction should be executed within a reasonable time frame. All the instructions should be executed in a given period of time. The time should be provided. To ensure that an algorithm produces the expected output, it should be checked using sample values. To ensure that an algorithm produces the expected output, to ensure what the output we should want, okay, it should be checked using sample values. It should be checked by taking some of the other values. Okay. Here some of the algorithms have been given in front of you. The first is example of algorithm to pack your school bag. Second, algorithm to calculate the sum and the average of three numbers. Third, algorithm to make a grilled sandwich. Fourth, algorithm to compare two numbers and find the greater one. My dear students, read these four programs thoroughly, the algorithm, and if you have any problem, send me a message in my comment box and I will reply it. Okay. Next is your characteristics of an algorithm. Okay, guys. Characteristics of an algorithm. A good algorithm should possess the following features. To perform the good algorithm, we should have some features. All the features should be included in it. The first name is your input. An algorithm accepts an input. It's true. Algorithm accepts an input. We provide an input in our algorithm. Wait for a while, students. Second here is generality. An algorithm works on a set of input. It always works what the input you provide. Definitives. Definiteness. Each instruction should be written in a simple and precise manner so that everyone can understand it. We have read this process, we have read this sentence in an instruction to create the algorithm. Uniqueness. Each step in an algorithm should be uniquely identified and an output of each step should depend on the previous step. What we say? Each and every step should be uniquely identified, and output of each step means each next step will depend on the previous step to get the correct output. Finiteness. It should involve finite number of steps to reach a solution. It should have finite number, means it is not been given that once it should move only for one time, it should go for only for 2 times. Means to get the solution, it can move for a several number of times. The process can run for several number of times. Next is your output. After the instructions are executed, the user must get the desired result. Okay. After all the instructions are completed, after all the instructions are executed, we get our desired output, desired result. What we have created that program. Okay, student, we have completed here algorithm, and next we will move for a flowchart. I have told it before only, before starting the lesson, that flowchart is nothing but the diagrammatic representative of your algorithm. What we have created there we don't have any diagram, but in a flowchart we will have a diagrams. Each and every diagram have different meaning in our flowchart. Some stand for input output, some stand for your process, some stand for your start stop box, some stand for your condition. Okay, these are some of the diagrams which are used to create your flowchart. So let's start it. A flowchart is a pictorial representation of the state or an algorithm used to solve a particular problem. I have told you before only. The process of drawing a flowchart for an algorithm is known as flowcharting. After the algorithm, we create the flowchart, and that is known as flowcharting. It graphically represents the logic need to solve a programming problem. Just as a picture is worth 1,000 words, similarly, a flowchart provides a much better way to solve a problem than writing a lot of descriptive text. Okay, to solve the many, as when we create the complex program, so in that when we start to write in an algorithm, it becomes a long process. Okay, to solve that means confusion, we generally use flowchart instead of our descriptive text. The flowchart uses different symbols to represent different types of instructions which are connected to each other with the help of flow line. Okay, we provide different instructions, different input, okay, in a different symbol, but they are connected with the help of flow lines given over here. These are flow lines. Okay, students. So different symbols and their functions. What is the use of these symbols and what are their functions? What are basically their uses in our flowchart? We have discussed over here. The first one is, you can see it is in a form of oval. Okay, this is known as your start stop box. Before starting any program in a flowchart, we should use this box, and after the end of the program, we will use this box to display the start and the stop. It is used in the beginning and the ending of the flowchart. Okay, in the beginning and the end of the flowchart. Next is your this. You can see this is a perpendicular. This is known as your input-output box. It is used for accepting input or giving output of the program. In before, after start, providing an input, and before and getting an output, we will use this box to display input and output. Third is your processing box. Rectangle shape processing box. It is used to for writing the processing instruction and doing calculation. How we have to perform calculation on the input. Okay, how we have to perform process on an input. What are the steps? Some formulas that we will write in this processing box. This diamond type, this is known as decision or condition box. It is used for checking or applying any condition in the program. It is used to applying any condition, for any condition, true, false condition. This type of condition will be applied by using this decision box. Flow line. This is used to connect one symbol to another symbol, means one process to another process. Flow line shows the direction in which the control of the program is moving. These arrows are used to connect the various geometric symbols in a flowchart. Okay. Flow, to show the flow of your flowchart. Last is your connectors. These are used to connect one part of the flowchart to another. If we are connecting two different programs, or we are continuing this one program, we are writing it on our notebook. If we find that half of the program on this page and half program are on another page, so we will use this connector to display that. Okay. So students, today we have discussed the topic like algorithm, what are the characteristics of algorithm, and a flow chart, and what are the diagrams, and what are the basic uses of the diagram in a flow chart. So this much is enough today, and in our next class we will discuss about features of a flow chart. So thank you, have a nice day.